Welcome back to our short video series on hand tools that you need in maintenance engineering. This is for anyone who's just starting out. Maybe you're an apprentice, maybe you're just interested, maybe you haven't got a dad in your life. So we're going to talk about the use and deployment of this particular hand tool. So this is an electrical screwdriver, and we'll get into the components right now. So what we have here is the handle. Then this section here is the shank. On the end, we have the blade, and then on the end of that is the tip. So getting straight into it, how do we check that this is okay? So we're looking for the serviceability of this screwdriver. So when I say that, what am I talking about? We're looking for any excessive damage to the handle. We want to make sure that it is firmly attached. We would be looking to the shank, and in this case the insulation. There are a few marks on it where it's used, however the insulation on the shank has not been punctured. We would then be looking for the condition of the blade, and we can see there are no chips outside of that. And then the tip, we want to make sure that the tip isn't damaged. If you have a damaged tip, you probably want to see a doctor, but in this case the screwdriver is okay. So in terms of maintenance for a screwdriver, there really isn't much outside of keeping it clean and not treating it like a chisel. This is not a chisel. Okay, if you need a chisel, get a chisel. This is not for scraping and scooping and smashing or whacking with a hammer. Equally, this is an electrical screwdriver, which means that we don't want to use it for mechanical tasks. This is a mechanical screwdriver. We can see that they have similarities. And if I get a wood screw here, we can see that the wood screw mates with the mechanical screwdriver, and equally with the electrical screwdriver. It is not appropriate to use electrical screwdrivers for mechanical work. The reason being is that an electrical screwdriver is designed for use on electrical work, which is obvious. However, the screws that you would screw in on electrical work are much softer and require kinder hands. A mechanical screwdriver, which is probably closer to a chisel than an electrical screwdriver, can take more of a battering. This can be used with some stronger force than you'd want to apply with an electrical screwdriver. Right, okay, so let's look at some reasons that you might have problems tightening and untightening something. So the first thing is that you've made the wrong selection of screwdriver for the task. Like we just showed with the screw, both of these mate inside the head of the screw very well. If you select a smaller screwdriver or the wrong shape and try and force it in, it's going to cause problems. If you over tighten the screw that you're tightening up, you're going to cause problems by damaging the head of the screw, and that's okay. However, what I would say to you is that in maintenance, the best situation is that you always think of the next guy. Always think about the next guy with the work that you're doing, because you might be the next guy. So if you're the kind of tool who's going to over tighten it, strip the head and cause problems, you might have to go back to that job, and then you've got to extract it. Ensure that you align whatever it is that you're screwing in so that it's straight. If it's not straight, when you tighten it up, you can slip and you can damage the screw, cause yourself problems, and it can pick up. You also have an issue with electrical stuff where you can cross thread them. Now, if we were to apply the same level of force, and this is a small 24-volt power supply, if we were to apply the same amount of force to this machine screw here when tightening up the terminal that we would with a mechanical screwdriver and a screw, not only are we going to strip the head, but we're probably going to strip the threads, cause problems. And in the world of maintenance engineering, every maintenance engineer will tell you that he's been to a job where somebody else didn't think they were going back to it, and they've caused aggro and problems. The part itself could be good, but because the screws are wrecked, it causes additional headaches. Equally, it's a frustration to see someone deploying an electrical screwdriver like it's a mechanical screwdriver, and you don't want to do it the other way around. This is not insulated and becomes a significant safety risk the moment you start using this in electrical panels. In maintenance engineering, there is a requirement to do live working sometimes because you need to be able to test the circuits and you will cause yourself problems. That being said, there are more extreme examples of things. Now, this is a bit set, which can be used in conjunction with a battery drill. You should never ever be using one of these in an electrical panel. It's absolutely worth noting that no good can come from this. And if you're buzzing up terminal screws with a battery drill, you need to have a serious think about what you're doing, because you are definitely going to strip the head. Do not strike screwdrivers with hammers or mallets. Now, that's not okay in any situation either. There shouldn't be a reason for you to be battering a screwdriver with a hammer, like I said, or a mallet in this instance. Like I said in the beginning, if you need a chisel, just get a chisel. And as always, if you're getting into maintenance engineering, the message is be humble, learn, and don't be a